Hi, so in this series we're going to look at solving trigonometric, I never really say that right, I'll say it trigonometric trig functions. So they look quite complicated. Those are the kind of stuff you see in the background of a Big Bang Theory episode. This is when the math starts to look very, very mathsy, but it is formulaic. There's a good process to work through. The same themes come up over and over again. So we'll try and go through, I think I've got 6-7 questions lined up over a few videos, and by the end of that you should be getting into the process of how we do things. So what is the value of this? Now the first thing here to notice is that this is in radians rather than degrees. So if I was to draw out, let's see, I'll draw out the cast diagram. Now this is effectively, it's like taking our function and putting it into a circle. So if you just look at your circle, we know that our circle has got 360 degrees in it. That's what the length of our standard sine, cos, and tan function are, 360 degrees. If I draw out sine, it does this, and it ends at 360. And same with cos and tan. I'll just draw these out. And this is really just describing what's happening on these lines up until 360. Now we say that 360 degrees is equal to 2 pi radians. So 180 degrees, if I half it, is then going to give me pi radians, and 90 degrees would therefore give me pi over 2 radians, etc. So yeah, on this cast diagram, I could say that, well, the full length is going to be, let's get rid of this as well, the full length is going to be 2 pi, so all the way around will be 2 pi, so 2 pi is up here, starting at 0, and over here at the halfway point I've got pi. That makes this pi over 2, and this between 1 and 2, I've got 1 pi, 2 pi, so that's 1.5, and instead of 1.5 I'll say 3 pi over 3 over 2 pi. So that's the radians first of all. Okay. The other thing I want to think about when we're doing finding values as paper 1 without any calculator, we need to know our 2 exact value triangles. So have these in the back of your head and draw these out anytime you're asked to solve when it's a non-calculator paper. So they're both right angles. I've got 30 and 60, obviously it's not drawn to scale. This is your 1, 1, root 2, and this is your root 3, 2, and 1. So Pythagoras will show you these work, this squared. In fact, sorry, I've got them on the wrong way. Pythagoras will show you that won't work. Root 3, 2, and 1. This squared plus this squared is this squared plus this squared is this squared. And I always think the 3's go together here, the 3 and the 3. So then obviously if that's 30, that's 90, that's going to be 60, and these are the same. Okay, so it's not too much to remember. You should kind of have that quite easily. So if I'm doing sine of pi over 3, well, I'll just say to myself, okay, well, sine pi over 3, pi is 180, so a third of that will be 60. So that's the same as sine 60. So I'm going to do sine of 60, and I'm going to take away cos of, now if that's 180, 5 times 180 divided by 4 is going to come out as cos 225. Ooh, now let's do the sine 60 first. Opposite what I put on is root 3 over 2. Okay, that's nice and simple, root 3, 2. This one, we've got an exact triangle for this, but if we look at our cost diagram, we'll see that, and maybe actually draw that a bit bigger over here. We'll see that it's the same values that kind of pop up over and over again. So for example, here, when I've got cos is 90, my answer is 0. So I follow along there, I get 0. Same as at cos 180. Go along, that's going to give me 0. Up here, I've got cos is 0, and that's giving me an answer of 1. 1, 0, negative 1. And over here, cos of 360, that's going to give me, that's not 180, that's 180 in the middle. Apologies. That's 270. It's a Saturday, guys. Saturday, the brain's not always turned on. So the 270 gives me the same, 180 would give me the negative 1, but these two give me 1. So you get the same values over and over again. So we're saying, where's cos 225? That's going to be somewhere between these two numbers. Yeah, it's going to be somewhere in there. That value, if I go along, would give me the same as this value. And actually, those two values then repeated up here and up here, because whatever value we get here is going to be on this graph at some point as well, isn't there? So we've got these kind of 4 answers that would almost, these are negatives to positive, but we're getting similar values, yeah? So on this value, on this graph here, if I was to draw in 225, we go all the way along to here, and that's 225. And what the cast diagram does is helps us work out, well, what's the other value that corresponds with that? You know, in here we say that 180 plus x is what's the value given. In this quadrant it's 180 take away x, and here it's x, and here it's 360 take away x. So I want to know what the x is. I want to know what the first quadrant is, because I like working with numbers up to 90 degrees. So if I've got 225, and I know I'm in this quadrant then, 225 take away the 180 means that x has to be 45. So a value of 45 degrees, so if that there is 45 degrees, that's giving me the same value as these values. Okay. So cos of 225, I can rewrite that as cos of 45. However, in this quadrant, cos is negative. Cos is positive here and here, so negative cos 45. Which makes sense, doesn't it? Because look, this is negatives, this is positives. So cos of 45 is the same value as negative, sorry, cos of 225 is the same as negative cos 45. It actually kind of works better up here, you know, if you look at the sine graph. So I'll look over here. So say this value, let's go along with that. Yeah. If I was to say that this was, I don't know, 60 degrees or something, say that's 60, I'm going to get the same value over here. If I do x 180 take away 60, that value of 120 is going to give me the same value back the way. Right. So just a wee bit of thought about the graphs and what we're doing, right? The main thing to take away is this is how we convert to radians. We need to know an exact value of triangles, and the minute we get a value like this, we have to look at our cast diagram and say, okay, where is it in the cast diagram? It's in here. That's up to 90, 180, 270. So I'm in here. So what's my value of x? Because I can work with values in here. Don't really like working with values out there. Okay. So cos of 45 is 1 over root 2. So it's root 3 over 2. And that's going to be plus 1 over root 2. And that's your final answer. So this bit was quite easy. This was a slightly trickier bit of having to understand your cast diagram. Pardon me. Okay, so the next one, same again. Solving the equation. First thing you want to do is get cos on its own. So I'm going to say cos x is equal to root 3 over 2. We just get cos to one side. We'll see this is in radians as well, so make sure our answer comes in radians. How do we solve that? Okay, well, x is equal to cos, inverse cos, root 3 over 2. I have to use my exact value triangle. So that's 30, 60, root 3, 2, and 1. So cos is adjacent over hypotenuse, so the root 3 is the adjacent, and I keep mixing them up, that's really annoying. I'm doing that. Adjacent over hypotenuse. So if that's the adjacent and that's the hypotenuse, then this has to be 30 degrees. So I've got x is equal to 30 degrees. And then I'm saying, okay, where else? So there's another solution to that, isn't there? If you look at my graph. Yep, at that value, yes, that's my 30 degrees in there. There's going to be a value, but look, there's another value over here that also solves the equation. And that's where the cast diagram comes in. So all you have to do is say, I'm in here and I'm in here, because I'm looking for when cos is root 3 over 2. And when's cos positive? It's positive here, it's positive here. So this is x, and this is 360 take away x. So one of my solutions is just x is equal to 30, and the other one is x is equal to 330. Simple as that. So you're looking to say when is cos positive, because this is positive. So that's the a and the c, that's all on cos, that's sine and tan. So sine's positive in these two. And then you have to remember your little formula for each of the quadrants. So as 180 take away x, as 180 plus x. And the very last thing we'll do is we'll just convert that into radians. So this one is going to be pi over 6, because I know that pi is equal to 180. And this one is going to be 11 pi over 6. 11 pi over 6. Because I'll do 2 pi take away pi over 6. 2 pi is 360 take away that, make them the same. 12 pi over 2 take away. Sorry, pause that. There you go, that makes sense. So I hope that was helpful. Thanks.